Today we're going to be looking at our study guide for our 5th unit test. Let's begin. First question asks you to write a ratio in 3 ways. So we have 7 zebras to 8 kangaroos. Okay, so we're going to start off with 7 zebras to 8 kangaroos. Kangaroos. We're going to do it 3 ways. So we have 7 zebras to 8 kangaroos. And then we have 7 zebras, semicolon, or colon I should say, to 8 kangaroos. There we go. We've got our 3 ratios. The most common one you'll see a lot of times is this one here. Let's continue. We have a half a cup of soup and 5 cups of rice. So we'll do a half a cup of soup over 5 cups of rice. We have a half a cup of soup over 5, not over, colon, 5 cups of rice. We have a half a cup of soup, half a cup of soup, to 5 cups of rice. So we have 1, we have 2, we have 3. Number 3. The money used in Jordan is called the dinar. The exchange rate is $3 to 2 dinar. Find how many dollars you would receive if you exchanged 22 dinars. Now I'm going to ask you that you set up a proportion to solve this. Let's continue. Feel free to pause the video and try this on your own if you'd like. So we have $3 over 2 dinar is equal to, okay, so we have 22 dinar, so does that go on the top or the bottom? What do you think? Well, it goes on the bottom because we need to have dinar, 2 dinar. Remember, the question is how many dollars would you receive for 22 dinar? So we'll go ahead and cross multiply. So we do 3 times 22, which is 66. And then 2 times x, which is 2x. Next, we divide both sides by 2 to get x is equal to 33. So how many dollars would you receive if you exchanged 22 dinars? Well, you would receive $33. Let's continue. Jenny was planning a trip to the UAE. Before going, she did some research and learned the exchange rate is 4 dirhams for every $1. How many dirhams would she get if she exchanged $5? So remember, we're setting up a proportion to solve this. So let's begin. We have 4 dirhams. 4 dirhams over $1. And we have $5, so does the dollars go on the top or the bottom? Yeah, it goes on the bottom. That's exactly right. Good job. So we get an X on the top. Okay, so now we have a proportion, so we can go ahead and cross multiply. You get 1x is equal to 20. You can divide both sides by 1 to cancel out the 1s, and to get x is equal to 20. So how many dirhams would you get if you exchanged $5? If you said 20, you were correct. Good job. Let's continue. Wow, this is a lot similar to this question here, so let's go ahead and solve. Using cross products, we get 2p is equal to 8 times 13, which is 104. Divide both sides by 2. 104 divided by 2 is 52. So there we go. So the P is equal to 52. Let's continue. We have 4 over 9.5 is equal to 2 over x. So let's begin by doing cross products. 4x is equal to, we're going to have to multiply 9.5 times 2. 18, that's 190. Move the decimal over, we get 19. Okay, so now we need to divide both sides by 4. Right, so I have 19 over 4. Okay, so I know, let's see, the number on the outside of the TP is 4. So I give myself enough space here. Let's see, so if this goes in there 4 times, I get 16. 3. Add a 0. Add a 0. 4 times 7 is 4.7. Then we have 30 minus 28, which is 2. Add a 0. And so we get 4.75. So answer is 4.75. Let's continue with number 7. The question says, are these proportional? Okay, so there's a couple different ways to tell whether a table is proportional, and you may see on your test this table that instead of runs up and down, it might run side to side. Okay, so the first way to tell really easily is if you notice that the pattern 1, 2, 3, 4 is going up by the same each time, and then with the fact that it's increasing by 1, this is also increasing by 3 each time. Now you may look at this question and just look at these first 3 numbers and say this is proportional, but you have to be careful because this last 2 numbers here, they increase by not by 3. So one way to check is just to simply say, okay, well they're all increasing by the same amount, but you want to be careful with that. So another way to check is to do cross products. So you're going to take this one and this one and get 6, and this one and this one and get 6. That works, right? But you want to check all the numbers. So you do this one and this one, you get 36. And you do this one and this one and you get 48. So it's not proportional. No, it's not proportional. It's proportional. Oh. Because the rate of change is not consistent each time. Okay, and also their opposite numbers are not proportional either. So it's kind of like setting up like we did with equivalent ratios in a previous lesson. Let's go ahead and move on to number 8. So first of all, I'm going to look to see if the pattern is increasing by the same each time, and I notice that it's not. So before you jump to conclusions and say this is not proportional, think about how much it's increasing. So this went up by 2 to 3. This jumped up by 2. Now if I draw in a 4, and say 8, well I notice that the pattern does actually increase by the same each time. They just skipped a number in this example. But to double check our work, we're going to go ahead and we're going to do cross products here. We get 12, we get 12. Okay, well that's a good sign. Let's do this here. We get 200, and we get 200. Okay. So then we can say that in fact that these are proportional. Yes. Okay, because the numbers, the rate of change how much it's changing each time is consistent. Also, by checking our equivalent ratios. Number 9, it says, find the unit rate. You have 152 bottles in 8 hours. How many bottles do you produce per hour? So remember, ratios, unit rates are set up as ratios. Now remember the difference between rates and ratios. As remember, a unit rate, do you remember, is a comparison of two different things, while a ratio is a comparison of the same thing. So bottles and hours are not related. Okay, so to find the unit rate, all you have to do is make it over 1. So we'll begin by dividing both of these by 2. So we have 152 divided by 2, which is 76, over 4. Now notice how these both end in an even number, so I'm going to divide them again. So it's 76 divided by 2, which is 38, over 2. And then again, an even number, divided by 2 again, to get 19, over 1. So how many bottles per means 1? 19 bottles per hour. So the unit rate is 19 bottles per hour. Let's go on to number 10. So we did, it cost $33.60 for 30 boxes. How much does the cost per box? So you have a nice little boxing company here, so you're trying to figure out what your unit cost is. Unit cost, unit price, same. So we're going to begin by writing it as a rate, like this, comparison of two different things, boxes. Then, if you remember from our last example, we need to make sure this is over 1. Okay, now it's going to be a little bit messy because we have decimals here, so let's go ahead and divide. $30 can't go into 3, but 30 can go into 33 one time. 33 minus 30 is 3. Bring down my 6. Put the decimal up here. 30 times what gets you 36? It's going to be 1. Bring down my 0. 30 goes into 62 times. 60 is squeezing in there. So we end up with 112. There's no remainder. 112. 1.12. So if the cost was $33.60 for 30 boxes, what is it per box? Well, it happens to be $1.12 per box. You draw plans of your living room using a scale of a ½ inch equals 2 feet. What are the actual dimensions of your room if your drawing is 4.5 inches by 8 inches? Okay, so we have a living room, a drawing, that is 4.5 by 8 inches. You're trying to figure out what the actual size of your living room is. So we want to use a proportion to figure this out, so let's begin. I'm going to start off by picking one of my two dimensions here for my drawing and just creating a proportion for that. So I have 1/2 inch over 2 feet is equal to, well, I'm picking 1, so I'll do 4.5 to start. And because it's inches on the top, I need to make sure I do inches on the top here. Alright, so now I can do 2 times 4.5, which is 9. And I'll do 1/2 times x, which is 1/2 x. Now I have a one-step equation here. So I'm going to go ahead, and because it's division, I'm going to do keep, change, flip. And do keep, change, flip. So I'll do 9 times 2, which is 18. And I get x is equal to 18. So one of the sides of my drawings is 18. So I'm going to do the other side now. That's the first part. You can pause the video if you'd like and try to set up a second proportion. So again, I'll use the same scale, which is a half. And the other side was 2 feet. 2 feet is equal to, and we'll pick the other number, which is 8. And again, we're talking about inches here because we're talking about the drawing. So we have 8 inches. Okay, so let's go ahead and figure out what the other side is. So we have 8 times 2, which is 16. And a half times x is 1/2 x. So we're dividing here, so we'll do keep, change, flip. Whatever you do to one side, you do the other side. Change, flip. So you get 32 is equal to x. Our 2 dimensions for an actual size of our living room is we have 18 here. And we have 32 here. There we go. And just to give you an idea of what the proportions look like, here's the first one again. You need to see that. And then here was the second one. Great. On a map, the key indicates that 2.5 centimeters equals 10 miles. A road on the map runs for 30 centimeters. How long is the road? Okay, so we're going to set up a proportion to figure this question out here. Let's see, so we have 2.5 centimeters over 10 miles is equal to, we have 30 centimeters here, so that goes on the top, over x. So we'll use cross products to figure out what x is. 2.5 x is equal to 300. Because 10 times 30 is 300. Divide both sides by 2.5. .5 goes outside the TP. 300 goes inside. Do you remember what you're supposed to do with the decimal on the outside? I'm going to have to move it over. That means if I move this one over, I also have to move this one over as well. Now I have 25, 3,000. 25 can go into 30 one time, with the remainder of 5. 25 can go into 52 times, the remainder is 0. 0 times 25 is 0, and I end up with 120. So x is equal to 120. So how long is the road? If the map runs 30 centimeters, well, the road is 120 miles. Let's look at number 13. It says, name all the corresponding sides, write them as ratios, and prove similarity. Okay, so let's begin. The good news is that these are in the same position, basically. These two shapes are. So we have the left side here. So we're going to have AB, line segment AB, corresponds to DE. We have, this is part A, so that's part A. We have AC, corresponds with DF. We have CB corresponds to FE. FE. Okay. So there we go. We have all of our corresponding sides. Now we want to write those as ratios, so we'll just say this is part B here. So we're going to just write those on top of each other. AB corresponds with DE. And then we have AC corresponds with DF. And we have CB corresponds with FE. Okay, so now we've written all of our different sides here, so we can go ahead and write the numbers in for our part C now. So part C is 8 over 4. And AC is 12 over 6. And then we have CB, which is 10. And we have FE, which is 5. Okay, so lastly we want to make sure that we want to simplify these, so we'll get 2, 2, and 2. And to double check to make sure these are similar, we're going to check the angles, and it looks like all the angles are the same. So we can say that these are similar. Yes, there. Now in the next part, in question 14, is going to ask to prove why they're similar. So looking back on the previous question, when we were asked to prove whether these are similar or not, in a complete sentence, explain why you said yes or no. So feel free to pause the video and try this on your own if you'd like. Okay. Well, the reason why they're similar, yes, the sides are proportional. The sides are proportional. And we checked all 3 sides, okay, which is really important. And then also, their angles are also congruent. The angles are congruent. Do you remember what congruent means? Well, congruent means the same. Remember, copy in terms of your angles. Congruent, same. Okay, great. Let's move on to number 15. Number 15 says, Jim is building a model airplane and the scale is 1 inch is 25 feet. The actual length of the plane is 450 feet. How long will the model be? Okay, so we are missing just one little thing here. I'm going to set up a proportion to solve this. So feel free to pause the video and try this on your own before you kind of see how I did it. Okay, so we're going to use a proportion. We have 1 inch over 25 feet is equal to, well, we got 450, so that's going to go on the bottom. We have x. Alright, so now we're going to cross multiply, and we get 25x is equal to 450. Now we can divide both sides by 25. And 450 divided by 25 is 18. So x is equal to 18. So how long will the model plane be? And let's see. It'll be 18 inches long. 18 inches long. Number 16. We have 2 trees that are similar to each other. This is 12 by x and this is 30 by 80. You have to figure out what x is. Feel free to pause the video and try this on your own. So we want to set up a proportion. So you could set this up in many different ways and you're still going to get the same answer. So let's go ahead and let's do bottom to bottom, side to side. So I have 12 is equal to 30 over x over 80. Now we can solve this using cross products. So let's do x times 30 to get 30x. And 12 times 80, which is 960. Then I'll divide both sides by 30. (960) divided by 30, so I'll get 30. 960. 9 can't go into 30, but it can go into 96 3 times. 9 times 3 is 90. Subtract 96 from 90 to get 6. Bring down a 0. 30 goes into 60 2 times. 30 times 2 is 60. And there we go, I get 32. So x is equal to 32. So the missing side then, the missing height of this tree is 32. A postcard of a building, this is number 17, measures 3 centimeters by 6 centimeters. If the scale factor is 1 over 400, what is the actual distance of the building? So let's begin. So we have 3. We're going to set up a proportion to solve this. Over x is equal to 1 over 400. I'll cross multiply. X times 1 is 1x. 3 times 400 is 1200. Divide both sides by 1 to get x is 1200. Now I'll do the same thing with my other side. So I have 6 over x is equal to 1 over 400. Cross multiply. So I get 1x is equal to 2400. Divide by 1, and x is 2400. So my 2 dimensions for my building are 1200 by 2400. That's it for our study guide. I want to thank you for tuning in.